Reading decimals. Let's look at a place value chart. The numbers to the left of the decimal point we have already covered. Ones, tens, hundreds, thousands, 10,000s, 100,000s, millions. All your whole numbers are to the left of the decimal point. The decimal point is here, and now parts of whole numbers, or the decimal part of the number, is to the right of the decimal point. These are tenths. Notice that tenths has one place because there's 1 0 in 10. Hundredths, thousandths, 10,000ths, 100,000ths, millionths. Each of these has the number of spaces as there are zeros in the denominator. So remember, the whole numbers are to the left of the decimal point, and the decimal numbers, or parts of whole numbers, are to the right of the decimal point. Let's try now to read a decimal number. To read a decimal, you first are going to look at the whole number and read that part. 14. The decimal itself is read as the word and. So we have 14 and. We have 3 spaces, or 3 places, past the decimal point. We need to say tenths, hundredths, thousands. Since the 6 is in the thousands column, this is read as 6 thousandths. So we have 14 and 6 thousandths. If we look at our second example, we have 0.0072. There is no whole number, so we do not need to read the decimal point as the word and. We can just read our decimal part. Since we have 4 places past the decimal point, tenths, hundredths, thousandths, 10,000ths. The 72 ends in the 10,000ths column, so this decimal is read as 72 10,000ths. So remember, if there is a whole number before the decimal point, read the whole number, use the word and to read the decimal, and then read your decimal part. When there is no whole number, there is no need to read the word and, just read the decimal part. Let's look at some more examples. 3.04. This is tenths, hundredths. So we read this as 3 and 4 hundredths. 4.3. This is 3 tenths, so it's 4 and 3 tenths. 0.8, remember, has no whole number, so there's no need to read the word and. One place, the tenths column, this is read as 8 tenths. 0.146, we have tenths, hundredths, thousandths. So this is 146 thousandths. Read the number, say the last column. If we look at this one, 70 is a whole number. 70 and tenths, hundredths, thousandths, 10,000ths, 100,000ths. Since the 85 ends in the 100,000ths column, we read this number as 70 and 85 100,000ths. Our last example, 9.000062. We know the whole number is read 9 and. Let's count our places. Tenths, hundredths, thousands, 10,000ths, 100,000ths, millionths. The 62 ends in the millionths column, so we read this last decimal as 9 and 62 millionths.
These are precision gauge blocks, so they come in various tolerances, which is a +8 and -4. But that +8 and -4, we're going to use this figure here. These are closer to tolerance. But notice the units are in millionth of an inch. And the ones that we're going to be using is +8 millionths and -4 millionths. And what I'm going to do is demonstrate what a millionth, 1,000, 10,000s, 100,000s, and 1 millionth give you a little comparison of what it really means. Now this is 0.001 is 1,000. Your hair is basically, and I'm going to draw it big, give you understand, your hair is approximately 0.002 This is 10,000s. In other words, 10,000s, if that's 0.02, it's dividing your hair into 20 pieces, the thickness of your hair. That's what 10,000s is equivalent to. 100,000s is 0.0001, and 1 millionth is 0.00001. So these gauge blocks, as was demonstrated, are ground precisely within the tolerances of plus 8 millions minus 4 millions. Or, if we write the number, 8 within that tolerance. So you can see it's a very close fit when you're talking about plus 8 millions minus 4 millions. I like to demonstrate the tolerance of 10,000ths, what it is like. We've made this block of steel over here, and to give you an idea, this is made out of 2 pieces of metal. It's hardened steel, and we made this piece fit into it. It gives you an idea, and we made it so it's a slip fit, so just the air escaping is escaping. Now we can make a press fit, or that you have to tap it in, but you can see how close that is. And this will just fade down, going in. It's just escaping air through the sides. That's how accurate we can cut with wire EDM. Within plus or minus, in machine terms, is 1/10, we say, but it's also 10,000ths. Now what I'm going to do, I'm going to take this piece to demonstrate when it doesn't have the air resistance. Now watch what happens, and I just move it over to the side. It slips right down. Now I'm going to take this and show you how precise wire EDM, that's what our company specializes in, can cut. I'm going to remove this snowflake. As you can see, it's even difficult, and I can rotate it in any position, and now I have to line it up precisely. So it has to be exactly, so you notice, any position, and I come over here, and as you can see, it goes right in.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.